Hey guys, this is Carrie, and in this video we're going to be doing homework number 6 for our answer key. So to do cube root of 125, we have to break 125 down. 5 times 25 is 125, and then 5 and 5. So 1, 2, 3, we get the cube root of 5 cubed. So this is really nice because we made a group of 3, and we see that cube roots and cubes cancel, giving us just 5. For the next problem, we see that we have a cube root of a negative. We can find negatives are okay because this is odd. The index is odd. Let me just use the vocabulary. The root is odd, let me just say. And so we start off by making everything negative. And then to find the cube root of 27, we would break it down similar to before. And in this case, you should get -3 as your final answer when you do break things down. For problem C, we're trying to find an even root of a negative number, so this does not exist. Next up, for problem number 2, determine the solution set to this equation. So we've got to solve for x. We multiply by 2 on both sides. We get x cubed minus 5 equals 120. We add 5 on both sides. We get x cubed equals 125. And we saw before, to cancel a cube, we need to use a cube root on both sides of the equation. So cube roots and cubes cancel, giving us x equals, from before, 5. Determine the equation of the curve sketched below. So focusing on the vertex, I see the vertex moves 4 to the right and 3 up. So we get y equals the cube root of x minus 4, because we're moving opposite of what we expect with the inside transformation, plus 3, because the outside is as you expect. Simplify the expression below to simplest radical form. So for this one, we have a square root. So I would like to find something's squared to cancel out with the square root. But we don't have that immediately obvious. So we have to break down this 125. 125 breaks down to 5 and 25. 25 breaks into 5 and 5. So we've got the square root of, and instead of writing it as 5 cubed, I think it's better to write it as 5 squared with one extra 5 right here. Now next up for x to the 10th. X to the 10th, I think we've found a shortcut at this point for doing the variables, so I'm just going to leave them as they are. So let's do this. Square roots and squares cancel here, giving us a 5 outside, but we also end up with this 5 still inside of the square root. Now next up, we've seen that because we're going to be pairing up these x to the 10th, we'll be able to make 5 pairs with no leftovers, because 5 times 2 gives us the 10 total power. So we get x to the 5th outside from those pairs, y to the 12th outside from the 12 pairs we make with this, and z to the 103rd with the pairs that we make with the z. But when you do 207 divided by 2, you get 103.5. So there's actually some extra left inside. This is 103 pairs, but 103 times 2 is 206, so we have one extra z inside still. And this is what we get. Simplify the expression below to simplest radical form. So to handle the variables, it's actually pretty easy. We're going to be making groups of 4. So when we have 12 x's, we can make 3 groups of 4, so that's x cubed. From 12 divided by 4. Because this is a 4th root, we're trying to make groups of 4, so with 30, we do 30 divided by 4, and we find that we can make 7 full groups. But doing 7 times 4, that's only 28, so we need to have 2 extras in order to make the complete 30. So that will be 7 full groups, y to the 7th, and then inside of our 4th root, we still have 48, and we still have y squared from the 2 extra. Now we need to break the 48 down, so 48 breaks down into 12 and 4, 4 and 3, 2, 2, 2, 2. So we end up with a group of 4 2's. That's going to have 2 to the 4th and the 4th root canceling. So we get 2x cubed y to the 7th times the 4th root of 3, that was ungrouped, y squared. Determine each of the following. So we have 125 to the 2/3. And before we get to these ones, actually, I think it's easier to do 7. So for 7, we have rewrite the following as a fractional exponent. So we're trying to rewrite it as something that looks like this. So what we saw in class is that the power will go on top and the root will go on the bottom. So in our case, we have the 5th root and the 4th power. So we have x to the 4/5. Next up, determine each of the following. Back to problem 6. So when we have 125 to the 2/3, we have 125 power on top, root on the bottom. Now you can do it like this, but 125 squared is a really big number. So you could also try to do it the opposite way, which would be cube root of 125, and then the power is still 2. So what I'm emphasizing here is the order doesn't matter. You can square it first and then cube it, or cube it and then, cube root it and then square it. And in my case, I actually would prefer to do it this way, because cube root of 125 we saw earlier is 5, and then when we square it, we get 25. All right, next up for b, let's try to rewrite this one. So for b, we get second root of negative 64 to the 3rd power, because power is on top. All right, but can you take the second root of negative 64? No, because you can't take the even root of a negative. And so that actually gives us impossible to do here. I'm going to leave you guys to try C, and I'm going to finish by looking at 8. So 8 looks really terrible, but it turns out it's one step away from looking like a problem that we've already solved in this homework. So to solve this one, the first thing to realize is you got a 1/3 power. So it's best to think about this as a power and a root. So we're going to do all of this to the 1st power, but when you raise something to the 1st power, that just means you have that thing once. So that doesn't change it. But then we do need to do the 3rd root right here. So we have this whole thing to the 1/3 power. Now we've got it as a root. So the last steps here are to put it all together and actually solve it. So negative means that the final answer will be negative because it's a cube root. 162 we need to break down. So 2 and 81, 9 and 9, 3 and 3, 3 and 3. So do we have any perfect cubes here? Yeah, we've got 3 cubed and 3 and 2. So if we look at the cube root of that, cube root and cube is going to cancel there, giving us a 3 outside, but inside we'll still have that 6. Now because we're trying to make groups of 3 with the a to the 60th, we'll be able to make 20 full groups with no leftovers, since 60 divided by 3 is 20 full groups. If we try to do the same thing with b though, we do 14 divided by 3, we find that we get 4 full groups with 2 extras. So b to the 4th from the full groups, and then 2 extras will be b squared inside. So the key thing with some of these fractional exponent problems is to rewrite them using the roots that we're more familiar with. I hope you found this video helpful, and I'll see you in class tomorrow.